All right, so this chapter is all about solving what we call system of equations. If you're really good at solving equations and understand algebra, it shouldn't be too bad. So let's get started. So the first part is, what is a system of linear equations? Okay, and a system of linear equations is two or more equations with two or more variables. Okay, what this means is I can have an equation such as 3x plus 4y equals 9. Then I can have another equation with y equals 5x plus 1, right? If you look, I have two equations and I have two variables in each equation, okay? That's what we call a system of equation. Now, what is the solution to this system of equation? The solution is an ordered pair that makes all of the equations true. So I have to find the value of x and y, and when I plug them into each equation, it would make a true statement. Okay, now there are three methods to solving this. One is graphing, another is substitution, and elimination. We will be starting with the graphing method, but before we go and talk about that, let's talk about what a solution means. So it says determine if 6, negative 1 is a solution to this system of equations, right? In this ordered pair, we know x has a value of 6, y has a value of negative 1. So what I'm going to do here is I'm going to plug 6, negative 1 up into this top equation. So I'm going to say 2 times, kick x out, replace it with 6, plus 5 times, I'm going to replace y with negative 1, equals 7. Now, if I evaluate this, is 12 plus negative 5, or minus 5, going to equal 7? Well, yes, 7 equals 7. So 6, negative 1 makes this a true statement, but we have to make sure it makes the second equation true. So negative, I'm going to kick out x and replace it with 6, plus 2 times y is negative 1. So is negative 6 plus 2 times negative 1 equal to negative 8 now, right? So it's negative 6, 2 times negative 1 is negative 2. Will that equal negative 8, right? And yes, negative 8 equals negative 8. Therefore, 6, negative 1 is a solution to this system of equations, right? When we look at the one below, right, is 7 2 a solution to this system, right? So here, x is 7, now y is 2. So if I substitute those values in, is 7 minus 2 equal to 5? Yes. 5 is equal to 5. So we know it works there. But if I do 3 times 7 plus 2, is that equal to 3? 21 plus 2, is that equal to 3? No, it is not. Therefore, 7 2 is not a solution to this system. Okay? So, a couple of things. We're going to basically work it, and we're just going to go here. The first way to solve a system, right, is by graphing, right? So now, generally, the equations up above are linear equations. And the solution to a linear system, right, is going to be the intersection. So the solution to a system is the point where the two graphs intersect. Okay? That is the key part here to know and understand. So right away when I look at this first example, I have the red line and the blue line. All right, where is this solution going to exist? Or where do the lines intersect? These lines intersect at 1, 2, 3, 4. 1, 2, 3, 4, 5. So the solution to this system is at 4, 5. Okay. Now the next one, number 2, the solution to this system is going to be at negative 2, comma, negative 1. That's where the solution to that will be. Now, how do we, generally do this? Well, here's the thing. The first thing we have to do is graph each line. So I'm going to graph this line here, and I'm going to say, all right, my y-intercept B is 0, 1, right? I get that from the 1 there. my slope is the number in front of x, which is 1. So it's 1 over 1, which tells me to go up 1, right 1. So I'm going to plot my y-intercept 0, 1. And then from here, I'm going to go up 1 over 1. I'll go up 1 over 1, up 1 over 1. And now I can sketch this line. Now, the tough part about the graphing method is you have to be very, 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 very accurate with your graphing. The next line I'm going to draw is this line here, where my slope is 1/2, the number in front of x, right, which tells me to go up 1, right 2, and then my y-intercept is 0, 3. So I'm going to go 0, 3, plot my point, and then this tells me to go up 1 over 2. I'm going to go up 1 over 2 again, and I'm going to graph this line. So that last chapter comes into play here. Now, where do I see these two lines intersecting? Well, right away, I know this ordered pair, the intersection, is at 4, 5, which ends up being the solution to this system. And if I plug this ordered pair in, right, if x is 4 and y is 5, it's 5 equals 1 times 4 plus 1. Does 5 equal 5? Yes. The next one is 5 equal to 1/2 times 4 plus 3. Half of 4 is 2. Is 2 plus 3 equal to 5? Yes. So that is the solution. It's the ordered pair that makes both of those true. The next one, slope of this line is 1. The y-intercept is at 0, -2. So I'm going to plot 0, -2. And since my slope is 1, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. And I'm going to draw my line. The next line, right, is going to be -x plus 4, where my slope is -1 now. So I'm going to go down 1, right 1. Then my y-intercept is at 0, 4. So I'm going to go 1, 2, 3, 4. I'm going to go down 1, right 1, down 1, right 1. I'll actually do it one more time because you'll see why. And right away, when I look, that ends up being the solution at 1, 2, 3, comma 1. That is the solution to this system, 3, 1. And if I plug those in, right, 3, 1, y is 1, so is 1 equal to 3 minus 2? Yes. Is 1 equal to -3 plus 4? Yes. This ordered pair makes both of those equations true. Now when we look at tables, right, so here these are supposed to be a table. It'll show up on your printout a little better, right? How do we recognize the ordered pair solution in a table, right? Well, when I look here, right, all your x values are your independent variables, so you plug them in. So your solution is going to exist at the x value or ordered pair where the y values are the same. So if I look at this ordered pair, right, when x is 1, this equation had a y value of 8. And when x was 1, this has a y value of 8. So therefore, the ordered pair solution here would be x is 1, y is 8. So when I look over here, right, what would the solution to this be? So for this one, they want to guesstimate, right? Now, which y values are close to each other? If I look, these y values are close to each other, these y values are close together. Therefore, they're saying the solution is somewhere between, right, x value of 1.1 or 1.2, okay? Now, to identify the number of solutions, remember, if I have two parallel lines, do they intersect? No. Therefore, this would be no solution. So if you have parallel lines, meaning they have the same slope, that means they don't intersect and there would be no solution. Okay? If they have different slopes, they have different slopes, that means they will intersect and have one solution only. Okay, so when I look here, if I look at the slope of this line, it's 2. The slope of this line is 2. They have different y-intercepts, so these lines are parallel, right? Therefore, there is no solution. That's because parallel lines do not intersect. The next one, even if I go ahead and distribute, it doesn't matter, but I'll go ahead and do that anyways. So we get y equals 6x plus 6, and over here, y equals 6x plus 6, right? Now, what happens here, you get the same slope. But here's the thing, they also have the same y-intercept. So what happens is these are the same exact lines. And if you have same lines, that means you will have an infinite number of solutions. And that's because these lines will overlap and they're the same line, which means they have many ordered pairs in common. Okay, so if they didn't have the same slope, they would be there would be one solution. Okay, so the next one. Ariel and her friends purchased some drinks and pizza slices at the snack bar. Each drink cost $2 and each pizza slice was $4. They purchased $9 or 9 items and spent a total of $28. Write a system of equations to represent the situation. So what we're going to do is we're going to write one for the total number of items, and we're going to write another one for the total cost. Those are the two things we know, right? So when we write it for the number of items, do we know how many drinks they bought? No. So that's going to be D. Plus, how many pizza slices did we have? We don't know. But we know the number of drinks plus pizza slices has to add up to 9 total items. Now, how much is each drink? It's $2. So Q times the number of drinks, right? Plus, how much is each pizza slice? $4. So 4 times P. When you take the cost of the drinks and the cost of the pizza, what does that have to add up to? It has to add up to $28. This would be your system of equations for that scenario. Now, if we had to graph this, right? This is your D, this is your P. Let's just find 2 ordered pairs. If I said D was 0, right? Oh, if I had 0 drinks, then how many pizza slices would I have, right? I would have to have 9. So 0, 9, 2, 4, 6, 8, 9. 0, 9 would be 1 ordered pair. And if I said I had say I had 9 drinks, 9 drinks and 0 slices of pizza, that would be my other point. And that's what that first line would graph like. So this line here is this here. Now, the other one, if I think about it, let's just come up with some ordered pairs. If I buy 3 drinks, let's go 4 drinks. If I buy 4 drinks, that's $8. Which means if I buy 4 drinks, how many pizza slices would I have? Well, I spent $8, so I have 20 left. So it'd be 5 pizza slices. So 4 drinks, 2, 4 is 2, 4, 5 pizza slices. All right. Then the next one would be, say I bought 0 drinks, right? 0 drinks. If I bought 4 slices, or if it's $4 per slice of pizza, it'd be 7 slices of pizza. So 0, 2, 4, 6, 7 would be that equation. And if I graph the line, it would be here. All right. And right away, where do those intersect? At that one point I found, which is 4, 5, which means you bought 4 drinks and 5 slices of pizza. That's a little hard one because they didn't really do a good job of explaining how to graph those. Go ahead, try the quiz. Remember, If you're approaching 3 incorrect problems, stop and wait for me to conference.